So good morning, everybody. So you are welcome to the class for today. As stated, we always encourage us to join the forum as early as possible. We appreciate those participants that join very early. And our principle is we are not going to keep people waiting for others. No, we always encourage timeliness. So the program is going to commence right away. I want people to check. I hope by now you can see my screen. Participants who are live, so you can chat. You can chat in response to my question, please. Can you see my screen now? So waiting for response so that we can continue. Yes, okay, thank you very much. Thank you very much. Okay, that's a good one. So welcome to the class once again for this edition of our weekly get-together and towards democratizing AI, machine learning, and data science. So today we are going to continue from where we stopped last week, where we're going to be discussing how to learn machine learning and data science faster and be in a more productive way. So though today we are going to focus more on generalization. How do we share the generalization of our model? So which is going to talk about how to do training, testing, and validation formally. So this is part of our important clarification series. With the team, always let the data speak. Don't forget that. Always let the data speak. So our vision is towards making AI and machine learning accessible to everybody, ethical, and also life-changing positively. So this is why this program has been set up. You're all welcome, and you're all highly invited. You're all highly invited to kindly share with your friends, invite your colleagues, so that together we can all make this very unique technology accessible to everybody, irrespective of your background. This is why we call it AI for all. Everybody, engineer, librarian, lawyers, medical doctors, just mention it. is AI for all. This is the real title of our forum. AI for all. So all are invited. So in today's talk, like I said, we're going to further look at, okay, how can you can learn it, AI machine learning and data science faster, and then being very much productive. But today we'll be looking more into generalization. That is how you can check the performance of your model. However, before then, to carry everybody along, especially for those that just joined for the first time, I know there are lots of our members that are joining us for the first time. I welcome you all, and I can assure you, even though you are just joining, you can make up. It's not difficult. Just follow some of the guidelines we'll be providing, like some videos we'll be asking us to watch. Watch them, note down your questions, concerns, clarification. Another edition of this live session, you can be able to see for your clarification, ask your question, and you can know more, and others also can benefit from your questions. So this is the essence of the live session, so that you go study what we prescribe, and then you come back to ask your question. And that's why our presentation is going to take the first, maybe first half of the timing, while the later part will be dedicated to questions and answers. So we move. Again, I always remind us to check out this, why you can no longer ignore AI and machine learning. The impact and importance of artificial intelligence and machine learning, they are well documented in three of our videos. In live session also, it was recorded in our live sessions where we get into the idea of reasons why you can no longer ignore AI and machine learning. I strongly recommend for those who are here to watch the videos, please kindly check it out. That will be able to motivate you and let you see what you stand to gain and what you stand to lose if you ignore the system. We say generally machine learning modeling is more of an iterative platform where you start from data, you have your data, make it available, make it ready for modeling. Make it available for modeling. And then you can then check the performance, whether it is okay or you need more. As the case may be. You'll be able to know, maybe to go back, or if it is okay as it is. So you always have that particular privilege to go back. That's why we call it iterative. So you can always go back, check the performance. If it's not okay, you may go back to the algorithm modeling once again, change the algorithm, do the hyperparameter optimization, and also for that, in which I made more clear in the one I call the modified iterative machine learning modeling framework. The principle of let the data speak. So when you go back here, you can do a parameter tuning, you can change the algorithm, you can make ensemble, you can make hybrids, you can come up with new algorithm. Then sometimes you may have to go back to the data, feature engineering, where you can do a lot of things there. You can dumb down the feature, you can create more feature, you can do principal component analysis, feature reduction. Sometimes you may also do data transformation, like normalized forms and others, creating more features. And sometimes, if the performance is not also okay, you may have to go back to data preparation altogether, where you clean your data, undo the missing value, outlier treatment, and the likes. However, we always stress, when you bring in your data, always, once it is ready for modeling, don't do too much preprocessing. so that you don't miss the insights. Let the data speak says, let it go through first. Check the performance. If it's not going well, you can go back. You can always come back, normalize your data. Especially normalization is very common. It's not all problems, not all data set that benefit from normalization. Let the data speak is audible, telling us. We've seen cases whereby normalizing the data before checking the original data actually made the research team to miss the insight. They couldn't get what they were looking for. They couldn't achieve the expected outcome because they normalized too early. So let the actual data goes in, check the performance. Then if it needs improvement, normalization is one of the options, missing value treatment, outlier treatment, and also for others. Even missing value treatment that is considered almost important or almost compulsory. If you are of algorithm, it is not compulsory because decision tree algorithm, they have that inbuilt capacity or capability to missing value automatically. So they have the capacity, the capability to deal with missing value by themselves, the decision tree family. So whatever you want to use, always remember that you can always go back. That is why we call it the iterative modeling framework. So to first, we suggested for us how to learn it faster, especially for the sake of those who have just joined us. So you have to check out these videos. They are available on our YouTube channel. Pick up the link. These materials will be made available for us. So for the sake of those who just joined, they may not have it. It was made available last week. We also share it again for the benefit of those that just joined. Check out these 4 videos. They are revision video for us that will cover what you need to do about what is machine learning, how does it work, and how can you benefit from it. So once you are done with this, next you go to the practical implementation, where you can see here live how you can build your first data analytics solution using Weka. In Weka environment. You don't need to be a programmer to do that. For those who know how to program, that is a plus. Or if you don't know how to program, it's not a problem. You can build and deploy solution without writing a single code. So, and that is why we said this course is for all, machine learning and AI for all, irrespective of your background. So by the time you are done of the first 4, making 7 videos, you will have built your first machine learning based model. And all this you can do within just 1 afternoon. The whole is about 2.5 hours. You'll be done. So as you are watching the video, document, note down questions or clarification, which you can then seek for in the next edition. Or it becomes very, very important. You don't want to wait. You are so much motivated. You want to continue the learning even during the week. You don't want to wait till Saturday when you can ask this question. You can always reach out to us in the forum, and you can also private chat us to be able to provide the needed clarification that will prevent you from waiting for the weekend. We're always there towards seeing that we learn faster and acquire the benefit as soon as possible. So once you are done with that, you're good to go. So we always tell us, irrespective of where you are from, either you are from diverse background, you are not computer background, think of your area where you can use AI and machine learning modeling, build your first model, further think how you can improve what you build. For those from computer science background, think of where people need your help. Think around you. What can you solve for them? Yeah, theoretical research is okay, but the world is looking into what you can do that can benefit people. There are a lot of problems in the world. Try to use your computer knowledge to solve this problem for people. So identify where you think is highly needed, sustainability, environment, host of other, medical, oil and gas. Build the first model there. Further think of how you can even improve what you built earlier. And sometimes you may even develop new machine learning algorithm altogether. Come up with new algorithm or hybrid or new ensemble formalities and see how it can benefit you and benefit people. So this is the framework that we are going to always be referring to in all our engagements. And we always say, always let the data speak. Start with raw data set before applying too much preprocessing. And always use the iterative process idea. Always use the iterative process idea, which I just explained. Remember, machine learning is not a dogma. Try different algorithm and options. Somebody tells you this is the best algorithm, he doesn't really understand how machine learning works. There's no algorithm that is best in all situations. See, there's no algorithm that is best in all situations. So you need to check it. Is this one going to work? Then how do we start then? The principle is you start simple. You start simple. Start from simple algorithm, like k-nearest neighbor, a decision tree. Don't jump to deep learning. This is very common. If some publishing houses also are not helping matter, you want to solve a problem, KNN and decision tree can solve it for you, but somebody is expecting you to use deep learning because it's the name that is in vogue that everybody is looking for. But deep learning may not be able to solve that problem like KNN we do. We have seen practical examples where deep learning solve problem and achieve maybe like 83% accuracy, maximum that could be gotten. And KNN, as simple as it is, was able to get 95%. Why should I go for 83 when someone can do it in a simple way and achieving better result? So that is why we always say, let the data speak. Go for simple algorithm first and go towards more complicated algorithm. Except if you are dealing with video data set, images, or text data set, then deep learning is very important here because it has the capacity or the capability to extract feature from images, videos, text automatically without human intervention. So in that case, I always recommend to my students, why don't you build an hybrid model then? Let deep learning comes in to extract the feature for you. Once you extract the feature, send the feature to standard machine learning algorithm like KNN, support vector machine. Also, you can also send it to deep learning itself. Let the two of them generate results. Maybe this one is getting 92%. Support vector machine is getting like 96%. So I will go with deep learning combined with support vector machine to get the best of the best. Because we're always looking for the best, most accurate performance. So that's what we are looking for. So that is why don't just jump to an algorithm because it is in vogue, because it is popular, but go for the one that solves your problem in a better way. So remember, machine learning is not a dogma. You try different algorithms and options and always see that you let the data speak. Then you take the next step based on what you can deduce from the data modeling outcome so far. This is where experience matters. This is where experience matters. Where you may have to consult experts to be, oh, I'm not getting it. I'm not getting the expected result. What can I do to improve my work? Then they can be able to guide you appropriately. So other learning resources that can support you, especially for our newcomers, new members. See, you can check out, this is the book, Let the Data Speak. So release, I think in January, you can get it from here, can benefit us in learning the theoretical background and what it then says when we say let the data speak. Other resources include this machine learning made simple. So this is the exactly you want to understand here without coding. This is 2.5 hours crash course with Wika. So this is the same video I already referred to you before. The 7 videos I ask you to check out as new members. The same thing, some people, they don't like to watch things on YouTube. They like to have it on a course platform based on request. That was why we made those videos again available as course. So you can get them from seller.com. You can also get them from Udemy. They are well-curated courses. So validated and then approved for people's consumption. So you can check them out there also. But I can assure you, if you watch those 7 videos I earlier mentioned to you, it's the same thing you are covering in this course. So the options are yours. Either you watch it on the YouTube or you go online for the course purchase. Another one here is writing machine learning-based research papers. So, which is another course where it teaches us how to write machine learning-based research paper. You can be able to carry out your modeling and then write your paper from beginning to the end. It also comes with a free template on how machine learning-based research paper should be written and framed. Just pick it. It's a Microsoft Word document. Pick it and you can use. It's also available in Seller and also in the Udemy platform. And then, yeah, today, like I said, we want to look at the generalization. See, when you train a model, it's not the training that really the problem. We want to train and get the good result. This is what we really want. We want to train and get the excellent result. So we need to check. Is this thing good to give us? Is it going to give you the result? So when you want to use machine learning to solve a problem, we do predictive solution. This is the step. We have y is equal to f of x. This is the output. This is the prediction function. We also call it hypothesis function. Some people also call it model. When you say you want to build a model, that is the model you want to build. Then this is x. These are the feature. It can be image feature. It could be any other feature. It could be business transaction features. That's the characteristic of this is the, as we call it there, we call it the dependent variable. And this is the independent variable. Attribute that you can easily source for. You can easily get them. So once you have them, we usually have 2 steps. We usually have 2 steps, which is these 2 steps involve the training and then the testing, as they say. Though there's validation that is hidden somewhere, we'll talk about that now. So during the training, why? During training, this is where you can explain a machine learning model building to a layman. During training, why is known. We know why. You have the value of y, which is the output from past experience, from past data. X is the input. They are also known. We know the input. But y is unknown. So during the training, we don't know f. We are looking for an hypothesis function that can summarize for us the relationship between this x and y that is making our data to behave the way it is. For example, you have the characteristics of your patient in a clinic, the weight, the age, the gender, and some maybe questionnaires you have filled or some medical tests. The first patient is confirmed to be hypertensive. The second patient is confirmed not to be hypertensive. It's free. It's healthy. So as you show different patient data, and you keep telling the system, It will try to understand why is this hypertensive and this one is not hypertensive. The characteristic is what it's going to analyze. After checking several samples, maybe you are able to get like 1,000 samples for the training, finally to come up with the final hypothesis function, H. That later, during testing, Y is not known during testing. X is still known. We always know our X because it's easy to get the characteristics. And F is now known. You know, after the training, you already generated H, which is the F. You can call it hypothesis function, or we call it model. It's known. So when you have new samples that you want to check, you say Y is equal to F of X, X prime, where X prime is not in the training set. The X you want to check for was not part of the training set. That is what happened during the testing phase. So because you already have that age, then once you put it in, then it will tell us, okay, this is my new patient. Age, can you tell me this patient has age of 60? Is gender is male? Is maybe the parent has, yes, the father suffered from the same disease before, and other characteristics. Based on this, can you tell me if this patient is going to be hypertensive or not? Then it will generate result, yes or no, depending on the sample you provided. After doing that, we now see the output. We now compare it with the original output we have. Because in the testing set, we have the output, but we keep it away. We kept it away from the model. Now we can compare. Out of 200 samples for testing, how many were correctly classified? Then we can then move on and say, okay, this is the perfect accuracy. This is how we talk of training, testing in machine learning. This is a summary of it. Now, let's now see what we call generalization. You see, when you have the training label, generalization is how well does a trained model or a learned model generalize from the data it was trained in to the unseen one. You see, to the new one. How much was he able to generalize? That's what we mean by generalization. How well does a learned model generalize from the data it was trained on to a new test set? So look at this. I have a training model. This is a training set. Labels are known. We know the label. This is apple. This is pear. This is tomato. This is, you label them. As you are giving them, you are saying this is apple. You are training them. After the training, you say, yes, I'm okay now. It generates an hypothesis function H. Now, the testing set, which has the label unknown to the model. But to us, we know them. But we keep it away from the model we have built. We now say, okay, can you tell me what is this? He said, this is apple. What is this? He said, this is pear. This is tomatoes. Maybe out of these 6, he's able to get 5 correctly. He missed 1. We said the percent accuracy will be calculated as 5 divided by 6 times 100. This is what we call the generalization performance. So we are concerned with training, but the most important thing is how is it going to perform when you have new samples? And that is what we call the inductive learning hypothesis. If you train a model enough on a set of training data set, enough, if it performs, then it will perform on other data that may come in later that are yet unseen. This is the principle behind machine learning modeling. So if you do the right thing well, that will be great. Now to do the generalization, how do we check the generalization ability? There are basically 2 major ways of doing it. We have the hold out method. We call this hold out method. Hold out. for training. Now, this can be done in two ways. See, that is this first one. This is the second one, which we call resampling. When you have few data, we call it cross-validation, n-fold cross-validation. Your n can be 2, can be 3, can be 4, can be 5. But tenfold is very common. Tenfold cross-validation is very, very common. See? But for now, let's start with this first one, hold-out method. The hold-out method. The hold-out method can be implemented in two ways. The first one, you divide into 3 sets. The first is the training set. The second is the validation set. And the last but not the least is the testing set, which we usually call it publication set. You see, this is kept totally away from the system. Totally away from the system. So you don't use it during parameter optimization. However, once I do the training, I can use my validation set to check the performance. You see, I've trained my model. Now I need to check the performance of the model I just trained. I check the performance. It's not yet good. I go back again and I modified my model. Made like if I'm using k-nearest neighbor, KNN, K ranges from 1 to as many as possible. So initially K was equal to 1. I'll go back again. K is equal to 3. I'll run my training. After the training, I'll use this validation set to check it if it's fine. If it's not fine, I'll go back again. I change K to be equal to 5. That's why we call it validation set. You are using it to iterate, to check your model, to change the performance of your model for better. But note that this testing set is never used. Keep it outside totally. So once your validation set is saying, yes, what you are getting is reasonable, this is when you now put it into the system. We remove the output. The output is not 100. That will be your performance. 190 divided by 200 times 100. That means it's still making mistake on 10 samples. That is not too bad. But we want 100%, especially in medicine, or close to it. But there's always room for improvement. So this is the first implementation of holdout method. You divide your data into 3. And you do this if your data is big enough. If your data is not big, you can't afford that. That's why we have the second option. Majority of people follow this option because data is always limited. Data is the big issue, especially material sciences and the likes. You don't have enough data. So once you use this option, just like you did here, this testing set should never be used during the training. Take note of that. If you use it to check the upper parameter, it's not valid. There'll be leakage of data. We call data leakage. It has leaked. It is already leaked to the training set. It's not valid. Your experiment is null and void. So when you have only this, what do you do? Because I need to do hyperparameter optimization to know what is the parameter value for that algorithm that will be better for that data. Every data set comes with its own unique characteristics. So it is during hyperparameter optimization period that you'll be able to know which parameter value will suit this method, this data. Maybe this one now we got, assuming here we got K is equal to 5 as the best. Next time you bring another data, K may be equal to 1. That will be where you're going to get the best result. That's mean your K is equal to 1. Another time, you may get the best result when your K is equal to 11. So you have to check it. So it means you run your model, train it, check the performance validation to determine the best hyperparameter for you. See, you do cross validation. Which is this method. To train, you have done is okay. If it's not okay, you go back again, change the characteristics of your model, do the hyperparameter optimization, use validation set to check again until you are okay. Once you are okay, you bring in the testing set, which is the publication set. Now, for this one, so what you do is you can use the idea of hyperparameter optimization. You can use the idea of cross-validation, to check for hyperparameter values. How do we do that? We divide your data into parts. The same data. Don't touch this. Never use this in whenever you are doing your training. Testing set should never be used. It should be outside. So to know how to get this validation, now let us explain what we call the resampling idea. The resampling idea. Once you get that, then you bring it here and use it on the 75% data that you are having. So once you use cross-validation to check the upper fully now using that data, now build a model that is trained on 75%. And now you can now use the testing set to check it. Finally, so as I was saying, so the cross-validation, this is how it works. Yeah, this is the idea of the holdout method, where you divide into only two sets, training and then testing. So using this for training and then this one to validate your work, as case may be. Yeah, you see here, when we divide into better if your data is okay, it's certified. So when you divide it into three, building block, you divide your data The testing set is outside the building block. The testing set is outside the building block. So you have the training set, now you have the validation set that is going to be checking. If it's not okay, you go back again and do your hyperparameter modification, validate this again. Once you are done, then you build the final model, which comes out there. You can use your testing set to check finally where you have the final evaluation. It's an option. When you are using the hold out method, either you break into two or you break into only one. Yeah, for the disjoint, the one we call cross-validation, this is how it works. The second option, we use it when the data is not much, or we just want to get a quick proof of concept. You have the full data here. You divide it into like 10 partitions. Let's say I want to use n-fold, 10-fold cross-validation. You divide it into 10. See, these are 10 partitions. So the 9 portion, you use it for training. You use this to validate, to check if it's correct, what it's doing. Next, the one you use for validation before become part of the training set. You can see the color, this means training set. This portion become testing set or validation set. This one will make it easier for you to understand quickly. See, I have data set, I partition them into 10 places. Let's say I have like 1,000 samples. When you partition 1,000 samples to 10 places, I'm going to have 100 in each partition. So in the first state, I use this for testing. All the others, I use it to train. From here to the end, I use it for training. And I check the performance. I validate by running testing on this. So I record the result. Partition 1, the performance is 85%. Next, this one will become part of the training set. You can see why I use this for testing now. I record the result, 86%. You do that until every portion is used at least one time. It's used one time for testing. The final one, P10, partition 10, then I have like, maybe I got like 73%. This means I train, you see, portion 1 plus 2 plus 3. So this is going to be like 900 samples. I use this 100 to test. That means I'm done. I've done it for 10 partitions. Then you add the result together, total, find the average. This plus this plus this plus this plus all divided by 10, then you get the average. That's going to be the performance of your model. This is what we call n-fold cross-validation. N-fold cross-validation. And your n can be equal to 5. It could be 3. It could be 2, depending on the number of data you have. Sometimes we are given like 16 samples. So you can use 2-fold. 8. You see? Use it for training, use for testing. Again, use this for training and this for testing. Then find the average. Though the more the data, the better. So this is what we call the n-fold cross-validation, which is the second part of the type of partitioning our data. Now, I'm going to go back now and show us. Now you know what is n-fold cross-validation. So if you happen to divide your data into only 2, now during the training set, because you cannot use testing set to check your hyperparameter, you're going to pick this 75%. Let's say your 75% is like maybe 700 of the data. Let's say 700. You're going to divide it into like 10 places. That'll be 70, 70, 70 in 10 places. Use the first 9 to train and the last one to test, and you keep changing them. Second for testing, for validation, third for validation, fifth for that validation. At the end of the day, you're going to have 10 different results. You find the average and see what you're getting. And every time you change if you are not comfortable with the result, you change the upper parameters values. until you get the best value of K. Maybe it's 5 now. At that point, once you know the value of K that is better, now you set it up and use the entire 700 now for training. You now use the entire 700 for training. You already had the hyperparameter optimization, hyperparameter values, the right algorithm you want to use, build the final model using 700 samples. Once you are done, now come and pick this testing set to check the performance, and you can report your results. This is how you do holdout method when you are using only 2 partition A. When you have 3, that is easy. Use this for training, use this for validation, while you keep changing your hyperparameters. I hope that clarifies. So because of our time, we are going to stop at this point to take questions, clarification that we have from members, either new or old. By God's grace, we will continue from here. And then hopefully we, after shortly, we'll be moving towards looking into different applications of AI machine learning in different fields of study. They are series. We already had agriculture. We had 2 modules under agriculture: AI machine learning for plant production, AI machine learning for animal production. Then we move to the second phase, where we also treated peace, conflict, and resolution using AI machine learning. How can we use AI machine learning to support peace, conflict, security, and resolution of crisis? We had that for several weeks. All those videos you can find in our YouTube channel. We hope once we are done with what we're explaining now, we'll be moving towards other fields also. If itemize business administration, economics and society policy, if identify library, law, and the related concept, if identify some engineering, and other fields of studies, one after the other. If you have interest in your own field, you want us to also talk about that in one of our series, feel free to chat in the system, chat with us there. Tell us your area of interest that you want us to also look into. We are going to be taking them one after the other. But the unique thing for us is this. The unique thing I want you to take note of is, and the good news. So whenever we are discussing a particular area of interest, don't say, it's not my area they are treating. It doesn't matter because of something that is unique. Okay, let me tell you that. It's very, very important. After the training, you see, training is like you have a supervisor. You know the label. So after the training, I can now do the testing. I can discuss to do the prediction for you or identify what you want to identify. But the point I want to make is this. Applications are diverse, but the methods are generic. I want you to take note of this. Take home. Applications are diverse. If you listen carefully and see how we use it for agriculture, you will be able to use it in your own area. That is the good news. Because applications are so wide, but the methods are generic. The same procedure you took to use AI machine learning to build a model for peace and conflict solution, the same procedure you're going to use for when you're going to use for your own library area, when you're going to use for your economic principle, when you're going to use it on psychology area. It's also part of what we've listed. How can you use AI machine learning in psychology to make it easier for us? Is it in medical psychology, industrial psychology, and also for the application areas? So whenever one is being discussed, pay close attention, because the same method that is being discussed is cut across, is generic. The same procedure you're going to use in your own area of interest. And that is why I also recommend for us to check out those areas we've covered in agriculture, also in peace and conflict resolution. You see several identify, and also practical demonstration of such concepts. I believe that's a good way to stop for the day. Thank you very much for listening. So we are going to take some questions and answer as the case may be. Thank you. If you have questions, then you can raise up your hand for identification. Raise up your digital hand so we can recognize you. Okay. Okay, there's a question there. I have a question here. Let me answer that first. The question is saying, what is the difference between ensemble and hybrid model? Nice question. What's the difference between ensemble and hybrid model? You see, hybrid model and ensemble model, these days, they are getting closer and closer, just like any area. Things are, there is getting a kind of, the separation between them is getting thinner and thinner, because inside ensemble, you can have an hybrid. Inside an hybrid, you can put an ensemble. That's why people call it hybrid ensemble. You may have a single solution that has integrated with it hybrid and also ensemble. But in short, the difference is in hybrid model, they work more, even though that's why the generic definition may confuse you. I will use a sample to clarify it. So people used to say hybrid usually work in series. We also have ensemble model that work in series, like boosting. That's a very popular way of describing hybrid. Usually hybrid work in series, but there are ensemble also that work in series. That is, you do one, then you move to the next, then you move to the next. But majority of ensemble, they work in parallel. They work in parallel. But boosting work in series. When you do this, you wait for the result. Based on the result, you resample the data. Those the system is not understanding, could not understand them, we make it to appear more in the training set so that you can be able to understand them. That is boosting. You come back to all this detail later, and you can check out our videos on details on ensemble. We have several series on ensemble. You can find them on our YouTube channel. However, in short, I gave an example today when I said that you can use deep learning to extract the feature for feature extraction. Feature extraction. Because deep learning is very powerful in that. That's why you use it for autonomous vehicles to extract feature automatically from videos that are being taken and sensor that is coming in. So once you use deep learning for feature extraction and pass the feature extracted to support vector machine, this is an example of an hybrid. Very simple. This is an hybrid model. Deep learning extract the feature for me and then send it to support vector machine. This is an hybrid model. You are using more than two methods to work on the same problem. That is hybrid. Another way to look at it is, let's say I have fuzzy logic. Fuzzy logic. Fuzzy logic has the capacity to model uncertainty in data, especially type 2 fuzzy logic. Type 2 is a special type of fuzzy logic. It's able to really treat and handle serious uncertainty in your data set. So we use it to pre-process the data to handle the uncertainty. The outcome from this fuzzy logic, we now pass it to maybe k-nearest neighbor now, or decision tree. And after that, we get the result. This is another hybrid. That's an hybrid model. So whereby you let the data be processed using one method, while the outcome of that method go to the next method to do another thing. That is hybrid model. You have a kind of a sequential operation on the same data, but using different algorithms to do different things until you get the final model. Why in the ensemble, what we do in ensemble, there are several other examples of hybrid, but what we do in ensemble is this. Ensemble is like crowd, the power of the crowd. See, when you want to consult a medical doctor, maybe to go for knee surgery, it's better to consult many medical doctors. Don't just go for surgery because of one option, one medical opinion. The doctor may be mistaken, irrespective of his experience or her experience. So you seek for multiple opinions. Let's say you have consulted multiple medical doctors, like 15. 12 of them says, don't go for knee surgery. We have better way to treat it for you. Only 3 say go. You can make informed decision. 13, 12 against 3. See? So you are better, you are on safer side by seeking for different opinion. In similar way, so we can train this model to identify if a student will pass or fail. Model 1, model 2, model 3. This one say this student will pass. You say he will fail. You don't say he will pass. So I take voting. One of the methods of ensemble is voting, simple voting, majority vote. This is 3, 1, 2, 3. 2 say pass, 1 say fail. We go that the answer is going to be pass. See, we give more weight to the majority carries the vote. That's the simplistic ensemble model. So when the more model you train, the better. Imagine I train like 145 models to determine what's going to be, there's going to be a cyber security attack or not. Out of this 145, 140 says there will be no attack. Only 5 say there will be attack. So I go for the super majority, overwhelming majority. But sometimes we also do what we call the special type boosting, whereby, let's say this algorithm, this model, achieve 60% accuracy. This one also achieve 45% accuracy. But this guy had 99% accuracy. I will better times 2 or times 3. I give this guy times 3. The decision is times 3 because this guy has very poor performance. Poor performance. Even though they are saying this student pass, this guy is 3. 3 against 2. 1, 1. This is 2. 3 against 2. I'm going to go that the student is going to fail. So that we can work on the student, give him or her more tutorial, follow up so that the student will not fail. Sometimes you respect the opinion of more accurate model. And that is what we call boosting. Like you spoke with 3 medical doctors. One of them is a professor of medicine with more than 30 years of experience and advise you. And 2 other doctors, they are new doctors, maybe training doctors. They advise opposite to that of the professor. Only 2, maybe we will go with that full professors because we think that he has more experience than the other ones. This is what we call the boosting. We give more weight to the trusted opinion, even though it may go wrong. A professor may be wrong. Sometimes, yes, it's possible. Those junior doctors may be correct. That is why it means you multiply the mistake of that professor by 3. That's the problem of boosting ensemble. Now, finally, we came up with what we call stacking ensemble. So far, that's the best ensemble so far. We call this stacking. Stacking ensemble. We don't do majority voting. We don't do boosting voting, but we take the result from all these guys and use the outcome to train another model that will give us the final result. We can check out more detail about this different type of ensemble and the hybrid in our YouTube channel. You see them there. So in short, hybrid use multiple modeling in the kind of a sequential way. When we do one thing on the data, deep learning will extract the features, give it to support vector machine. Support vector will do the model and then do the prediction. That is hybrid model. Only one model is doing the final decision. That is hybrid model. But in ensemble, you are using different models to jointly vote to take a decision. Then the stacking, this is the visual of the stacking. That's why I say sometimes stacking means you train this model 1, model 2, model 3, you train them. They generate the output. The output they are generating, maybe the percentage of the could be the probability. Probability of belonging to class A is is 0.8. Probability of class B is 0.2. So we take 0.8 is 0.2 as new feature. We use them as new features to train another model this time around. It may now be support vector machine. So this is KNN, this is decision tree, this is XGBoost or whatever method you are using. Or yeah, or let's say we are using Naive Bayes. Now, finally, they all contribute their probability to be used in training support vector machine. Support vector machine will now use the outcome of these guys to now do final prediction, which is going to be either the student pass or the student fail. Now, some people say that this is a model, different model, is doing something on the data, generating result, and now we are training another model with it. Some people say this is more of an hybrid than an ensemble. But this is an ensemble type. That was why I said that as things are going, there's becoming a thin air between ensemble and hybrid. So what I call this one is an hybrid ensemble. Because inside it is an ensemble principle. They're in parallel, trying to solve problem in parallel. But the way we combine it in kind of an hybrid form. We're bringing in a totally new machine learning algorithm again to help us summarize whatever they have done by doing training and testing for it in another way. So this is how we can look at ensemble and hybrid. I hope that clarifies. Ensemble is more of trying to take kind of crowd opinion in taking decision. And in human point of view, a lot of evidence have pointed to the fact that it is the best way to take decision. For example, this very popular, there's really very popular experiment. In this very popular experiment, what happened? In the very popular experiment, what happened was you want students, they all brought to the class. You have a class of 100 students. They brought red, you bought a kind of a balloon. You gave them balloon, the same color. They have to write their name and their matric number on the balloon. And then they now gather the entire balloon, you shuffle them and throw it on the ground and ask them to pick their balloon individually. You know, each student will start looking for their balloon in his class of 100. A student may pick a balloon, 99 balloons, before he or she finally pick his or her own balloon. Because you pick it and check, it's not my own. You pick it and check, it's not my own. Until you pick like 99 and the 100 one he's picking is his or her own balloon. It takes a lot of time. It's an experiment, a social experiment. It demonstrated that it took so much time and the class became chaotic. Now, the second experiment, since your name is there, students just go to the balloon, pick any balloon, call the name of the balloon on the balloon, and give it to the owner of the balloon. Within few seconds of few minutes, all students got their balloon without trouble. That is the power of crowd, collaboration. So when you collaborate together, you can solve problems better than an individual model. And that is the big practical and theoretical principle behind the principle of ensemble learning. And several competitions out there have demonstrated that you want to get the best results, you go for ensemble. Like the popular Netflix competition, sometimes ago. Netflix placed $1 million on ground if you can improve their recommendation system by 10%. Just ordinary 10%. Team from different parts of the world. They couldn't make it. Towards the end of the competition, all the team came together and said, hey, guy, bring your model. Let us form an ensemble from our models. Because they were getting 6%, 7%. Nobody could cross the 10%. They brought all their models together to formulate an ensemble, and they were able to achieve that 10%, and then they got their prize, shared it among them. That is the power of ensemble, the power of the quantity coming together to collaborate and to take the better result decision, as the case may be. So hopefully that clarifies the difference between ensemble and hybrid. And sometimes you can build one. Yeah. Excellent. Thank you very much. I think it's made very clear there. Yeah. So I imagine diagnosing patient. So you take opinion of doctors to take the better decision. That is exactly what it is. So I believe that's the question we have for the day. So thank you all for listening. Again, I implore some of you already type in there. If you have your own area you want us to look at, so we'll be looking at it as the case may be. Yeah. Yeah. Okay. There's a question, a quick one. Sir, give a brief explanation on transfer learning and heterogeneous data set. Yeah. One, on the heterogeneous data set, what is a heterogeneous data set? Okay, let me start from the transfer learning you started with anyway. Transfer learning is when you have a model that is already trained. We call it pre-trained model. That model has been trained already. But now, for example, when you are working with images are very challenging to train. You want to train 10 million images from the scratch. You want to work on a similar problem. Maybe you want to identify people. And there is another model that has been trained that work on similar area. You will now pick that model, that pre-trained model. You pick it, and now bring it to your own model, and now add your own data. This is what we call transfer learning. The learning that has been done on that model before, you are transferring it to your own model that you are building now. It's like integrating what has been built before. Now you can add your own data now. Instead of starting from scratch, you're just going to increase upon that. So your own data has some own unique characteristics. You just add it to it. The system will benefit from the one that has been pre-trained to before because they are related. But you can't use transfer learning for areas that are not related together. That is why. But when they are related together, somebody already trained how to identify a set of images that are similar. But now you have gotten some images from your own area. Instead of training from the beginning, all from downloading and then training from the scratch, you already have a pre-trained model. You bring it in, and then you add your own training upon it. This is what we call the transfer learning. You are transferring what has been trained before into your own new system that you are trying to make it learn. So that is transfer learning. Then heterogeneous data. See, when you use heterogeneous data, this is when you are taking data from different sources. From different sources, or we can call that multi-source. But majorly, when you talk of heterogeneous, what people refer to as heterogeneous is this. You want to build cyber security authentication system. Usually, we can use iris. It's very popular to use iris. Your eye, the iris of your eye, they use it to identify you easily. That is number one. You have an application that uses it. You have another application that uses fingerprint. It's very common, fingerprint. That is it, to check authentication. Maybe you are the right person. We have another model again that is using, another solution that is using the new one detected the vein under the palm. The vein under your palm is a special one that has just been recently detected. That there's a vein under the palm of people that no two people share the same one, the same thing. So it's now being used. It's a new method. You have other ways. There's another one, body temperature. You use the body temperature. But heterogeneous data now is when you want to use combination of all this. I want to build a security system that will use iris, that will also use palm, fingerprint, that will show you have more than one type of feature. You see, that is what we call heterogeneous data. That data set is coming from different parts of human body. You have the fingerprint, you have the iris, you have the palm. You want to integrate everything together so that your security will be stronger compared to somebody that is using only one. Because somebody can bypass the finger. Some people don't have fingerprint. No matter how you do it, it will not show. So those people, how are we going to deal with them? Some people bypass the fingerprint due to fraud, and then you can see people issue passport again because the fingerprint has been bypassed. But if you use multi-feature system, some people also call it multimodal, whereby you are able to have, okay, we have the fingerprint, we have the facial, also facial recognition is there, apart from your iris, your entire face recognition is also there. And once you have different type of features being combined together in a data set, we say, okay, this is an heterogeneous data. Some people also look at it like in oil and gas now. They are not talking of security. In oil and gas, usually when we want to work in oil and gas, we take data from one reservoir. Sorry, from one well. A reservoir will have multiple wells. Well 1, well 2, well 3. We use data of well 1 to train and test well 1. We use data of well 2 to train well 2 and then well 2. We don't interchange them. Now we're proposing a new system whereby we can bring well 1, well 2, well 3, well 4, bring the data together, and then train and build it. This is heterogeneous data from different sources. The well 1 is different from well 2, is different from well 3, is different from well 4. Now we are bringing the data together and merging them together to train and test a model. That is also another heterogeneous data from the point of view of the oil and gas. When your data is having different sources, especially when it comes to the features and feature types. Hope that clarify to the questioner. Because of time, I think it's a good place to stop for the day. So, wishing you all the best. So don't forget to always invite your friend, let people know about it. Maybe you benefit them. A lot of people keep saying, oh, we didn't know this is taking place in all these days. I will join. It's never too late. Once you join the WhatsApp group. Coordinator can help us put the WhatsApp group there. If you are here to join the WhatsApp group, click and join. Please, coordinator, put the WhatsApp group number 3. The number 2 is full already. It's not accepting people. So put the link to WhatsApp group number 3 so that people can join, so that you get our announcement when we're going to meet and when we're not going to meet, and we'll be able to provide the necessary guidance for you. Thank you very much all for listening and wishing you all the best. So Dr. Mujisola is raising up, and that's our coordinator. You have the floor. Dr. Mujisola, you can unmute yourself now. You can talk.
Okay, thanks so much, Paul. Thanks for the wonderful class. May God reward you abundantly, sir. Yes, I have been trying to let in people into the platform 1, 2, 3. I know 1 is full, then the 2 is almost full. Even the 3, the community is telling me, or the system is telling me that the community is filled up. I cannot admit people. I don't really know where the problem is coming from. And I have tried everything.
Okay.
I've been working on it this morning. I don't know. If not, I would have posted the link on the platform. I have a student of mine that is already he attended this class and he has been struggling to join.
Okay. Thank you, doctor, for that effort. I noticed that I thought it was the 2 was full. I didn't get the error that it was the community that is full. That means, okay, we look into that. Community definitely have minimum and maximum they can allow. Then in that case, we'll look at the best solution. Perhaps we'll take the main forum out of the community so that there will be no restriction on the number. So it's an option. You can exit the community. 1, 2, 3, they can be separate from the community. Later, people can be added to the community. Or we look at the best solution to address it. Yeah, that is a technical one. Thank you very much for identifying that. I thought the number 2 is already full. So we look into that. So be on the lookout, and then again, bring your brothers and your sisters keeper by letting them know about this kind of opportunity for us to interact, exchange knowledge about AI, machine learning, and how you can use it in your various areas of interest. Thank you very much, our coordinator, for that, bringing that up. Hopefully, we'll get it resolved after the class. Thank you, and God bless.
Welcome, sir. Thanks so much, sir.
Thank you all for the messages. I wish you all the best. Just spread the news. Let more and more people benefit. That is our main target and motive. Thank you very much. See you in the next edition. Bye. Hmm? Okay.
Sorry, Prof. Greeting from Lagos. Assalamu alaikum, sir.
Alaikum salatu wa barakatuh. Prof, how are you, sir?
Adúpẹ́ o. Péjọ mẹ́ta, sir.
Longest, how's the family?
Thank God. Alhamdulillah.
Yeah.
Kàkí náà ni
Thank you very much.
ẹ̀kú effort náà. Allah will accept it
How's
from
the
us.
family? Our greetings to everybody. Hope they are all doing great.
Alhamdulillah. Alhamdulillah. That your boy is supposed to be contacting you also, but then I don't know because he's on his final project and he's also doing AI for pest detection and so on like that. So rounding it up, we should be buying some.
Thank you very much, sir.
No. It's okay, sir. You know, new circular pen.
Thank you, Dr. Abdulhamid. Eshigani, how is the Unilag? How are the people over there? My greetings to everybody. Greet a lot of people.
Greetings from Malaysia, Prof.
How are you?
I'm doing fine, Prof.
Nice, always nice having you, Dr. Benedict Onoja.
Yes, Prof.
Thank you very much. Been a very
Thank you, Prof.
consistent participant for years now. Thank you.
Thank you. Thank you, Prof.
You're welcome. You're always welcome.
Yes, Prof. Yes, Prof.
Mm.